In August 2026, SpaceX executed the largest tech acquisition in history. By absorbing Anysphere in a transaction valued at $60 billion, the company signaled a pivot toward total control of the artificial intelligence stack. The deal marks a rapid ascent for Anysphere. Founded by MIT alumni in 2022, its flagship platform, Cursor, gained widespread adoption by offering developers context-aware indexing and real-time multi-file editing. The acquisition was structured as an all-stock merger, converting Anysphere's equity into roughly 389 million shares of SpaceX Class A common stock. With the closing of the deal, the Cursor platform and its engineering talent have been folded into the newly established SpaceXAI division. SpaceX isn't just buying a software tool, it is attempting to build a closed-loop environment that addresses the economic bottlenecks currently slowing the growth of AI development. Before this merger, AI startups faced a significant operational hurdle. Most functioned as application layers, building their tools on top of foundational models they didn't own, hosted on hardware they didn't control. As user revenue grows, the third-party API costs required to power each code generation pass tend to climb even faster. For many software vendors, this creates a state of margin compression, where the cost of compute eventually eats the entire profit. This pressure intensified as the industry moved toward agentic workflows. These processes require continuous background reasoning and larger context windows, causing licensing fees to spike. Even with an annual revenue run rate surpassing $4 billion, Cursor remained tethered to this expensive, rented infrastructure. To protect its long-term margins, Cursor moved to replace variable API fees with fixed capital assets, securing direct ownership over the physical hardware that runs its code. The merger places the Cursor workspace directly atop SpaceX's internal server capacity, creating immediate technical alignment. Cursor's engineering teams no longer need to purchase external access. Instead, they utilize owned infrastructure, shifting their primary operational expenses into hardware assets. This setup creates a continuous data loop. Every developer interaction, system prompt, and debugging action recorded in Cursor generates telemetry that flows directly into SpaceXAI servers. That data feeds the fine-tuning pipelines for the Grok model series. By training on real-time developer behavior, SpaceX refines its 1.5 trillion parameter architectures with unprecedented specificity. These refined models then return to the Cursor interface, providing users with lower latency and higher completion accuracy. Under this architecture, every keystroke becomes a user point used to sharpen a sovereign AI model, creating a product advantage that is difficult for standalone software to match. This entire loop is anchored by the Colossus supercomputer in Memphis. Housing 200,000 Nvidia GPUs, it provides the computational throughput required for large-scale model training. SpaceX has used this hardware to create an unusual market dynamic. It acts as a primary infrastructure vendor to frontier AI labs while simultaneously competing against them in the software market. In May 2026, Anthropic signed a $45 billion agreement to use SpaceX Compute. Those $15 billion annual payments directly offset the capital required to build out the server footprint. Google followed with multi-billion-dollar enterprise agreements of its own. This creates a cycle where SpaceX's rivals are effectively bankrolling the hardware used to refine SpaceX's internal software. By monetizing excess capacity to competitors, SpaceX funds the rapid expansion of its own computing infrastructure. SpaceX plans to scale its ground-based footprint to 1 million GPUs, but that ambition is running into physical reality. Terrestrial data centers are constrained by the limitations of the North American power grid. Across the continent, electrical systems are nearing their structural capacity. Beyond electricity, new facilities face multi-year utility queues and the high water consumption required for evaporative cooling towers. These bottlenecks are worsening. Projections indicate that U.S. data center power consumption will double between 2025 and 2027, creating a supply chain crisis for ground-based compute. To maintain its trajectory, SpaceX has reached the limits of what can be built on the Earth's surface. To bypass the grid, SpaceX has filed for FCC authorization to launch 1 million solar-powered compute satellites into low Earth orbit. This schematic details the Star-9 AI-1 architecture. Its 70-meter wingspan powers a modular array of Nvidia processors. In orbit, it benefits from continuous solar radiation. For thermal management, 110 square meter radiators dissipate heat directly into the vacuum of space, bypassing ground-based environmental constraints. With the first orbital prototype tests scheduled for early 2027, the infrastructure required to support the cursor editor, the Memphis GPU clusters, and the StarMind orbital network, SpaceX has built a vertically integrated stack that spans from a developer's keyboard to the edge of the atmosphere.